let's learn about product rule in this video. We can start with a question. Find the derivative of x e to the power x. We already learned how to find the derivative of a sum or a difference. For example, if the function was x plus e to the power x, you know how to find the derivative. You find the derivative of first term, which is 1, the derivative using the power rule, plus the derivative of e to the power x. The derivative of an exponential term is the exponential term itself, e to the power x. So this is the derivative for the, and if it was the difference, x minus e to the power x, again, it's the same procedure. So you find the derivative of the first term minus the derivative of the second term. So your natural tendency will be to think, okay, to find the derivative of this one, find the derivative of the first term times the derivative of the second one, but that's wrong. So you need to find a special rule, which is product rule, to find the derivative of a product. And that's what we're going to learn in here. So if we have a function of the form y equals uv, in this case y equals x e to the power x. So if the function is of the form y equals uv, where u is a function of x and v is a function of x, in this case x is u and e to the power x is v. And if the function is of that form, the derivative y dash dy on dx equals u, the first term, times the derivative of the second term, plus second term times the derivative of the first term. And you can express this in alternate form in Leibniz notation, dy on dx, that's another way of writing y dash, equals u dv on dx plus v du on dx. Okay, this is also equally true, the same equation, two different ways of writing it. Okay, so we can use this equation now to find the derivative of x e to the power x. Let's do that now. Okay, so the equation for the derivative is y dash equals uv dash plus v u dash, and also we found we have the u equals x and v equals e to the power x. So in this equation, before we substitute, we need to find v dash and u dash. Let's find that before we substitute. So u dash is the derivative of x. That's using the power rule, is the n x to the power n minus 1. That's the derivative of the power. And 1 x to the power n minus 1. That's a 1 minus 1. That's equal to 0, or the derivative is 1. Okay, and then the derivative of v dash, and that equals the derivative of the exponential function is the function itself. Okay, now we can substitute that in here. U is x and v dash equals e to the power x plus v is e to the power x and u dash equals 1. Okay, so the answer now is x e to the power x plus e to the power x. If you want, you can make a rearrangement of this equation by writing e to the power x times x plus 1 by taking the common term outside. Okay, so this is how we do one example, and let's do one more example before we learn the quotient rule in the next video. So the next question is, find the derivative of x plus 3 times 3x plus 5, that's our function y. To do this one, even if you don't want to use the product rule, there is another mechanism that's to expand this one. So something like x times 3x times x times 5 plus 3 times 3x plus 3 times 5, and you will get an expanded form, something like 3x square plus 5x plus 9x plus 15, and that then when we simplify 3x square plus 14x plus 15, and then you can find the derivative of each term by term, and that will be y dash equals 6x using the power rule, and plus 14x, the derivative is 14, and the constant term has the derivative 0. So this is the derivative. And so this can be done by expanding and then differentiating term by term. This is not always useful. For example, if you had a power here and then power here, here, then the expansion is a little bit tedious, and then this method becomes very ineffective as the power becomes greater and greater. So we need a different method, and that's what the product rule offers. Okay, so let's do this example using the product rule as well, and then we can compare the result if you want. So it should be the same answer. Okay, so the product rule is saying y dash equals u v dash plus v u dash, where in this question we are taking this x plus 3 as u, so u is x plus 3 and v is 3x plus 5. Before we substitute, we can find the derivative u dash. U dash is the derivative of this one. The derivative of x is 1 using the power rule, and then plus the constant term has derivative 0. So this is the derivative 1. And v dash, the derivative is the derivative of first term, which is 3, because the derivative of x is 1, and plus the derivative of 5, which is 0. Okay, so that's very simple. So now u is x plus 3 and v dash is 3 plus v is 3x plus 5 and u dash is 1. Okay, so you can expand, you can simplify this if you want. So it's 3 times x plus 3 plus 3x plus 5. You can expand the brackets, so it's a 3x plus 9 plus 3x plus 5. So 3x and 3x can be combined together, so that then becomes 6x, and then 9 and 5 can be combined together, that's 14. So the answer is 6x plus 14. So that's the same result as we got in here. So for this particular question, you can use this method, expansion, or use the product rule. But when we have higher powers in the question, or if it's really hard to expand, you should consider using the product rule. I hope this rule makes sense to you now, and I would encourage you to do maximum questions possible before you start learning quotient rule.